You are given the utility function u is equal to ln of x1, x2 to the power of 4. The price of x1 and x2 are €4 and €2 respectively. You have a budget of €60. Maximize the utility function. So this is what we're going to be trying to optimize, utility. And our constraint is going to be that for item 1, the price is going to be €4. So 4 times x1, plus the price of item 2 is going to be €2, so 2 times x2, and our budget is going to be €60. So there's our constraint. This will be the m value, this will be the constraint portion when we set up our Lagrange function. So setting up our Lagrange function, x1, x2, and lambda, I'm going to have my utility plus lambda times m minus the constraint. Utility being what I'm trying to optimize. So this gives me ln of x1, x2 to the power of 4 plus lambda times my budget 60 minus 4x1 minus 2x2. So now to do the next step, I'm going to have to do derivatives. So I'm going to take this ln function and I'm going to break it up to make the derivatives easier. So before I do the derivatives, I'm going to break up this logarithm function. So I'm going to use my logarithm rules. What I get is ln of x1 plus 4 ln of x2. So now I take my first derivatives. So the derivative with respect to x1, for ln of x1, it's going to be 1 over x1. And then the next x1 term is in my constraint. So this is going to be plus lambda times -4. The next derivative is going to be with respect to x2. I have 4 ln of x2. That's going to be 4 over x2. And then the next x2 term is within the constraint. This is going to give me plus lambda times -2. And then I do my derivative with respect to lambda, which is my budget minus the constraint. Next step is to set these to be equal to 0. From the first equation, I can get moving 4 lambda over to the other side. I get 1 over x1 is equal to 4 lambda. From the next equation, moving 2 lambda over to the other side, I get 4 over x2 is equal to 2 lambda. So now what I'm going to do with these, this time I'm going to go 4 lambda, 1 over x1, is going to be equal to 2 times 2 lambda. So that's going to be 2 times 4 over x2. So I get 1 over x1 will be equal to 8 over x2. I'm going to take the reciprocal on both sides. What I can do is I can just flip these. It doesn't have to be complicated math. I'm just going to take the reciprocal on both sides. So I get x1 is equal to x2 over 8. Does anybody have any questions over those algebraic steps? The first thing I did, I said, instead of doing lambda is equal to lambda, why don't I just make it 4 lambda is equal to 4 lambda? So this we'll call this part here equation 1 and this part equation 2. Equation 1 should be equal to 2 times equation 2 because this is 2 lambda. So I have 1 over x1 is equal to 2 times 4 over x2. Does that make sense? I've got more ways of explaining it. Okay, so let's just do it that way. 1 lambda is equal to 1 over 4x1. And then with this one, I'm going to divide both sides by 2. Lambda is going to be equal to 4 over 2x2. That's going to give me 2 over x2. So then we're going to set lambda is equal to lambda. So 1 over 4x1 is going to be equal to 2 over x2. Now, the rule of reciprocals, like if you had something like half was equal to 1 over x, What is x going to be equal to? It's going to be equal to 2. That's right. Well, the rule of reciprocals is if you have two fractions like this, the reciprocals will be equal to each other. So a reciprocal is when you just flip it over. Invert the denominator and the numerator. So this would be 2 over 1 would be equal to x over 1. 2 is therefore equal to x. And that would also work, say you had another example. 1 over 4 is equal to 2 over x minus 3. Ooh, this one's trickier. Let's do reciprocals. So 4 over 1 would be equal to x minus 3 over 2. 4 times 2 would be 8, would be equal to x minus 3. Adding 3 to both sides, x would be equal to 11. Now let's test that by putting that back in to what we had over here. 2 over 11 minus 3 would be equal to 2 over 8, which would get reduced to 1 over 4. Yes, it would satisfy that equation. So the rule of reciprocals could also be used right here. So what I'm going to do is I'm going to take the reciprocal on this side and the reciprocal on this side. As long as I do it on both sides, I get 4x1 is equal to x2 over 2. I'm going to multiply both sides by 2. 8x1 will be equal to x2. So now what I'm going to do is I'm going to take this relationship and I'm going to substitute it into this expression right here. So now I have 60 minus 4x1 minus 2 times x2 is actually 8x1. It's another way we can write it. So I have 60 minus 4x1 minus 16x1 is equal to 0. 60 minus 20x1 is equal to 0. Moving my 20x1 to the other side, I get 60 is equal to 20x1. Dividing both sides by 20, I get x1 is equal to 3. So now I have my x1 value. Solving for x2 is equal to 8x1. So it's going to be 8 times 3. That is going to give me x2 equal to 24. The maximum utility, using my utility equation, is therefore going to be the ln of x1 is 3, x2 is 24, and this gives me my u max equal to 13.81.